Hello, pre-algebra students. Today's lesson is about dimensional analysis. No, this is not a self-portrait. This is just a cartoon that I ran across where this lady is at the grocery. She's shopping for apples. We've just finished talking about unit rate, and the sign here, if we look at this sign, it says apples are $1.99 a pound. So that is their unit rate per 1 pound. For unit rate, our goal is to get the denominator to be 1. So if she wants 2 pounds of apples, you can see the math in her thoughts over here to the right. If she's buying 2 pounds of apples and they're $1.99 per 1 pound, then she's going to have to pay $3.98. What happens? That turns into dollars. What happened to the pounds? Well, anything over itself is equal to 1. So this is understood over 1. So we had $1.99 times 2 pounds over 1 pound. So our pounds have canceled out, just like our ones would cancel and turn into 1. There's an old saying, I think my grandmother would say it a lot. She would say, well, that's 6 of one or half a dozen of another. An example that I thought of is if I'm passing out papers. Do I pass them out from the front of the room, or can I pass out papers, which I often do, from the back of the room? Well, my grandmother would say, oh, that's 6 of one or half a dozen of the other. In other words, half of a dozen is 6. So they're the same thing. It doesn't matter whether you say 6 or whether you say a half dozen. All right? $1.99 is 1 pound. So it really doesn't matter. Are we talking about 1 pound or are we talking about $1.99? In essence, they are equal to 1. They're the same thing. I'm trying to make a fat one. $1.99, one pound is $1.99. That's like saying the same thing. And then, of course, the pounds then cancel out. Excuse me, that's my alarm. The pounds cancel out, and that's what we want. We want to find out how many dollars. So in dimensional analysis, stay with me for a minute. This is where we're trying to go with our lesson today. In dimensional analysis, you need to cancel out the unit that you no longer need. And at the store, she knows she wants 2 pounds, but she needs to know how much money. So as we embark on dimensional analysis, think about what your unit rate is. That's bringing in the lesson from yesterday. And your unit rate, how you want to set that up, because I could have said 1 pound per $1.99, but I set it up in this way so that my pounds will cancel. So you have to begin these problems with the end in mind. Isn't that good advice for any problem? To approach the problem or begin the problem with the end in mind. All right, so stay with me while we fill in your notes that you have. So dimensional analysis, that's another name for converting rates and measurements. We're analyzing dimensions. It sounds much more intimidating when you say dimensional analysis. But we're talking about measurements, dimensions, and we are analyzing them. That's all it is. It's the process of including labels as you compute. Compute is math. As you are doing the math, you have measurement labels. We will use this method a lot in high school. I know you use it in physics, probably even in chemistry also. You may even do it some in science this year. So the most important thing to remember is a fraction that is the same on the top and on the bottom is always equal to 1. So if you end up like we did with our example problem with pound over pound, that equals 1. If you end up with centimeters over centimeters. That also equals 1. So keep the end in mind as you approach these problems. So let's start with number 1. We're going to convert 760 miles per hour per 1 hour. Okay, that's what it's given here, 760 miles per hour. I wrote that in red. And we want to convert that to miles per minute. So we want miles, but we want to change hour to minute. Now let's analyze that for just a second. You know that in 1 hour there are 60 minutes. All right, 1 hour and 60 minutes, that's 6 of one, half a dozen of the other, or that's saying the same thing. 60 minutes, we'll be finished in 60 minutes. Oh, okay, then we'll be finished in 1 hour. It doesn't matter, those are equal to 1. So it doesn't matter which way you write this, but I want my hour to cancel and to turn into minutes. See, that's the end in mind. So if I put hours on top and minutes on bottom, I'm going to put, just like I have written there, just so happens this time, 1 hour stays on top and 60 minutes stays on the bottom. But I could have written that vice versa. It doesn't matter. But I want hours to cancel. See? And so the math that I'm going to be doing is 760 divided by 60. But I have left here in my dimensions miles, that was left, over minutes. And that was the goal that I had for myself. Change it to miles per minute. And now I have miles per minute. So once you've set the problem up, the math is the easy part. The analyzing the dimensions is the hard part. So 760 divided by 60, I know my zeros cancel, and 6 goes into 76. It looks like it's a repeating decimal, so let's round up to 12.7 miles per minute. Okay, you could leave it over 1 if you'd like, make it all miles per 1 minute. That might be a great way for us to start. Let's start that way. Miles per 1 minute. We want 1 as our denominator. All right. Take just a second to see if you can set up B without me. Pause the video here and set up B. Okay, the first ratio is not hard. You are just reading convert 520 miles per year. So I wrote 520 miles per year. But we're converting miles per year to miles per month. So the unit that I need to change is year. I need year to become months. Well, I know that there are 12 months in 1 year. Okay, is that how I want to write it? 12 months over 1 year. Watch what happens if I write 12 months, maybe put an S on months, I think. 12 months to 1 year. That's a true statement. But my year is not going to cancel here. Oh, so it's going to be to my advantage since I can write that ratio, whether you're comparing months to years or years to months, it doesn't matter. The order I write, I'm going to put 1 year on top, 12 months on the bottom, because I need my year to cancel. Now I'm going to have 520 divided by 12, and that leaves me miles per month. So once I have my measurements taken care of, like I said, the math, you're welcome to use your calculator. 43.3 repeating, we'll just leave it at approximately 43.3 miles per 1 month. You could put an S for months, but it's really just 1 month, singular. All right, let's move on. Example 2. A swimming pool is being filled with water at 300 gallons per hour. So I'm just going to go ahead and write that down before I even read. Gallons per 1 hour. Okay, that's the rate per hour. So I know that's an understood 1 hour. All right, let's change colors now to read the second half of the question. How many quarts per, second is this. So this is the first time we've had to change not only the time, but the unit of measuring our volume here also. We've got to change our gallons and we have to change our hours. Now, we reviewed in class that mnemonic device for gallon. There are 4 quarts. Excuse me, that's also my alarm. I have to get ready for school now. 4 quarts in a gallon. So I can either write 4 quarts on top to 1 gallon, or I can put gallon on top. Looks to me like here I want gallons to be on the bottom. So 4 quarts to 1 gallon. That's going to allow my gallons to cancel. So yay, I've got my quarts. But hold on, I have to take care of hours. We want to convert hours. So let's talk about what we know about time. We know in 1 hour, we've already talked in the first examples about in 1 hour there are 60 minutes. Well, this allows, I'm going to keep multiplying. This is a string of conversions. I'm just making a string of unit rates going all the way across here. 1 hour, 60 minutes. As long as we have a 1 in our problem, we have a unit rate. So this allows me to get rid of hours, because hour over hour, if we multiplied this all the way out, we'd have hour over hour, and that's going to cancel. But I don't want minutes, I want seconds. So that means I have to think one more time about another unit rate. In 1 minute, there are 60 seconds. Now again, I could have written this in either order, but I put minutes on top because I'm trying to get rid of minutes, and I want to have seconds left. In the end, so my goal, the end that I have in sight, is to have quarts per second. So here I have quarts, and here I have seconds. So in the end, I'm looking for quarts per second, per 1 second. This is my goal, the end that I'm looking for. So now, since I've canceled out my units that I did not want, I'm ready to do the math. 300 times 4 times 1, which is of course not going to change its value. Then 1 times 1 times 60 times 60. So the math that I'm having to do here is 1200 divided by 3600, which simplifies. Notice how I'm not worried about my unit of measurement because I know I've gotten that taken care of. So when you divide 1200 by 3600, you get 0.3 repeating. So there's 0.3 repeating quarts per 1 second, and that was our goal. All right, I'm about out of time, so let's read example 2b together. The TGV is a high-speed rail train in France. At top speed, it runs an average of 320 kilometers per hour, or kilometers, 320 kilometers per 1 hour. All right, that's what we know. Now, what's the end? The end is how many meters per second is this going to be? So you might want to change colors. I want my final answer to be meters per second, per 1 second. So that's our goal. So I've got to convert, or actually you're going to convert kilometers to meters and hours to seconds. And so don't forget King Hector didn't barf drinking chocolate milk. We will review that in class, so you'll know exactly what I'm talking about there. We have to go from kilo to meters, and so that's going from a bigger unit of measure to a smaller unit of measure. So to send you off on your way, let me just help you out there. In 1 kilometer, there are 1,000 meters. Now, you ought to be able to do the hour conversion on your own. Give me your best effort. Jump right in. Have a good day.